on December 30th, 2021, the unthinkable happened. Peaceful suburbs of Denver, Colorado, looking forward to celebrating the start of a new year, endured an unprecedented evacuation due to a rapidly spreading winter wildfire called the Marshall Fire. It is the most destructive fire in Colorado history to date in terms of cost, numbering in the hundreds of millions, and in losses of structures, with over 1,000 homes and businesses destroyed. Fire is an integral component of numerous terrestrial ecosystems. However, recent record-breaking events, unprecedented losses, and escalating suppression costs have raised concerns over a new normal of increased fire activity and the onset of an era of megafires. Wildfires are extremely costly, not just in the dollars used to suppress them, which number in the billions, but in the millions of acres of forest that get consumed as well. Annually, wildfires burn more than 7.5 million acres, with most of this destruction in the West. This is equivalent in area to the Grand Canyon in Arizona, 6 times over. New research led by scientists at Colorado State University, the US Geological Survey, and the North Central Climate Adaptation Science Center has found compelling evidence that average fire events in regions of the United States are up to 4 times the size, triple the frequency, and more widespread in the 2000s than in the previous 2 decades. The most extreme fires are also larger, more common, and more likely to co-occur with other extreme fires.
One of the challenges of land and resource management in the north central region here in the United States is increasing wildfires, and the need is to think about the future. What areas might be more susceptible to fire in the future? What will be how fires will behave in the future, and also what the exposure is. And fire threatens both natural resources, national parks, species and habitats, and our communities.
When it comes to the Marshall Fire, how did it become so destructive in a relatively short time frame? Well, it was a perfect storm of conditions. An unusually wet spring supported the high growth of grasses in the prairies that cover much of the open space in Boulder County. This provided the tinder. Then extreme drought conditions, a very warm and dry August to December timeframe set in. Coupling this with the downslope windstorm that produced gusts exceeding 100 miles per hour, with sustained winds of over 45 miles per hour for 8 hours, led to a rapidly spreading winter wildfire. Anthropogenic effects, or the human touch, are likely influencing fire patterns across the country, not only indirectly through regional drying, like that seen here in the West, but also in a direct manner. During the last 2 decades, for example, human ignitions caused 84% of all fires in the continental US, representing approximately 40,000 fires per year. By introducing ignitions into dry landscapes, humans have tripled the length of the fire season and expanded the size of fire-prone areas. The future is fire. Thus, in order to adapt and build resilience to impacts, planners and stakeholders must account for how fire is changing and how it is impacting vulnerable ecosystems and communities. Managing grasslands and making use of prescribed burns are some of the most effective tools we have in dealing with the intensity and spread of fires, by reducing those fuels that would otherwise be available for a wildfire to consume.